A rocket is launched from the surface of the Earth. Now, this is a special condition. The engines fire immediately and get the rocket at 3,000 meters per second, and then the engines suddenly stop. So it becomes a projectile. Now, of course, it's a theoretical question. We just want to know how high up the rocket should go once it gets launched immediately from the surface, and we're launching from the South Pole. So we think to ourselves, this is just a conservation of energy equation. So the kinetic energy initially given here, if we ignore all air resistance, is going to go into the change in potential energy as the rocket goes from the surface up to some height somewhere down here. Okay, so the kinetic energy is then going to go into the change in gravitational potential energy. And we want to find the total height above the surface of the Earth. And of course, we'll need to calculate from the center of the Earth first out to that location. So the kinetic energy is then going to go into change in potential energy, but we need to use the equation that looks like this. The G, mass of the Earth, okay, mass of the rocket, multiplied by 1 over R1 minus 1 over R2. Okay, now let's put in the equation 1/2 mv squared for this. And of course, m stands for this little m here, and the capital M is for the mass of the Earth. That'll equal G, big M, little m, multiplied by 1 over R1 minus 1 over R2. And the masses will cross off. Now R1 will be the distance from the center to the beginning location of the rocket, and R2 will be from the center to the final location here. So then we have 1/2 v squared equals 6.67 times 10 to the minus 11. And we'll multiply that by the mass of the Earth. 5.98 times 10 to the 24th multiplied by 1 over 6.4 times 10 to the 6th minus 1 over R2. Now again, the radius of the Earth in meters is 6.4 times 10 to the 6th. And then the velocity there equals 3,000. Okay, so plug 3,000 where you see the velocity right there. Okay, and then we just have one unknown, okay, which is R2. You'll need to be careful when solving from R2 because there's a lot of algebra here, okay, that you would use to find it. Solving for R2, it's 6.9 times 10 to the 6 meters. Okay, now that's the distance from the center of the Earth out there. If we want to find the height above, then I will just take 6.9 times 10 to the 6 meters minus 6.4 times 10 to the 6 meters, which is the radius of the Earth. And that'll equal 5 times 10 to the 5th meters, or 500,000 kilometers above the Earth, the surface.